Hey guys, welcome back to the channel. If it's your first time here, my name is Aiden Potts and we go through math and physics tutorials as well as how to improve the mindset and the learning skills of a student. In this video, we're going to go over the reciprocal trigonometric functions. Those are secant, cosecant, and cotangent. We're going to go through what they mean, how to graph them, and how they come from the primary trigonometric functions, which are sine, cos, and tangent. By the end of this video, you'll understand where the cosecant, secant, and cotangent functions come from. You'll understand how to graph them and how to remember them. If you need to know where the primary trigonometric functions come from, and those are sine, cosine, and tangent, I did a video before that I'll link in the cards where we went through how the primary trigonometric functions all come from the unit circle. If you find this video helpful, I'd really appreciate you liking this video and subscribing to the channel to see more videos just like this. So for these reciprocal trigonometric functions, like I said, they're all based on the primary trigonometric functions, which are sine, cos, and tan. Here we're going to go through the sine of x graph, and then we're going to use that to show what the reciprocal of that would be, and that, in this case, it's cosecant. So first I'm going to plot all of the key points for the sine graph. So we have 0, 0, then we have 1, pi over 2, pi over 2, 1, we have pi, 0, we have 3 pi over 2, negative 1, and then finally 2 pi, 0. Now if I were to connect all of these points, I would get the sine graph. It's not very great, but that's typically, if it was drawn more continuously, or I guess a little bit more artistically, that's how it would look. So like I said, this reciprocal trigonometric function, in this case it's cosecant, and cosecant is 1 over sine of x. So what we're going to do is we're going to look at some of these key points and plot what 1 over sine of x would be. So at pi over 2, that's going to be a value of 1. So if we go down to here, 1 over 1 would still be 1. So we're going to have a point right here, and this you can say is 1. Similarly, we can look at where it's negative 1. So it's negative 1, well, 1 over negative 1 is still just negative 1. So those values actually don't change. This is negative 1 here. The thing that does change, though, is since it's 1 over sine of x, wherever sine of x equals 0, there's going to be a vertical asymptote there. So if you look at where sine of x is 0, it's at 0, pi, and 2 pi. So then we're going to have 3 vertical asymptotes, which are these blue lines here. So pi and 2 pi. So we know for these vertical asymptotes that the 1 over sine x function is going to get very close to but never touch. So, and we also have this other point here at pi over 2, 1. So we know it has to go through this point and touch, or get very close to touching but not actually touch, this 0 vertical asymptote and this pi vertical asymptote. We also know that here in this, I guess, range, or sorry, in this domain of 0 to pi, this function is positive. So we know that the reciprocal function is also going to be positive. By all of these factors, we can say that the cosecant function is going to look something like this. It's going to be like a U shape, like that. And over here, now it's going to be at the vertical asymptotes are at pi and 2 pi. So in this case, again, it's going to go through this point here. This is negative, or this 3 pi over 2, negative 1 point. And it's going to get very close to touching each of these blue lines, but never actually touch them. And again, because the sine function here is negative, from this pi to 2 pi, I guess, domain, this cosecant function is going to be negative as well. So it'll look something like this. Very similar, just parabola opening downwards. And that would be the cosecant function. So next we have secant function, and this is based on cos of x. So first let's plot all the points for cos of x. So at 0, 1 there's a point, then at pi over 2, 0 there's a point, and pi, negative 1, then 3 pi over 2, 0, and finally finishing the full period at 2 pi, 1. So if we now connect all of these points, the graph will look something like that. And again, could be drawn a little bit better, but you'll find it kind of difficult when you're drawing these functions. So just like the cosecant function, the secant function, which is based on cos, it's kind of counterintuitive, but I'll give you a tip in a little bit on how that works. Here we have vertical asymptotes wherever cos of x is equal to 0. So cos of x is equal to 0 at pi over 2 and 3 pi over 2. So that's where we draw these blue lines which represent vertical asymptotes. Now let's look at our points where the cos function is 1. So we have 0, 1, that's going to be where the secant function is also 1, because 1 over 1 is just going to give us the same value. And then again, let's look at -1, where the function is -1, so that's at pi. So down here, we're going to have a value of -1, and the secant function is going to go through that point. So here, because again, from 0 to pi over 2, the cos function is positive, the secant function is also going to be positive, so it's going to look something like this. And it could also go on this side, but I haven't really drawn the negative radians. So this would look like part of the, I guess, negative pi over 2 to pi over 2. It would be positive in that range. So from pi over 2 to 3 pi over 2, the cos function is actually negative. It's in this negative, it's below the x-axis here. So we know it's going to go through this point pi -1, and it's never going to touch this pi over 2 or 3 pi over 2. So we're going to have a function that looks like a parabola opening downwards, something like that. And then finally we can look at 3 pi over 2 to 2 pi, and it's going to go through 1 again, so I can draw this point, and this will be positive as well. So we'll have the function that looks something like that, and it'll continue that way. And this was the secant function. So sometimes I find it kind of hard to remember, if cosecant belongs to sine or cos, because they're kind of counterintuitive. But the way I do it to make sense in my mind is I go, okay, well, cosecant has a third letter that's an s, and that corresponds to sine. So that means that y, like that cosecant is really just, cosecant of x is really equal to 1 over sine of x, because the third letter matches the sine function. Similarly, if I look at the cos, if I look at secant, that third letter is c, so that belongs to cos. So we know that secant function, so sec x is equal to 1 over cos of x, again because of that third letter. So now before we move on to the cotangent graph, we'll look at tangent. So tan of x is equal to sine over cos. This means that whenever cos is 0, there's going to be a vertical asymptote at that value. So cos is 0 at pi over 2 and 3 pi over 2. Now, because sine is in the numerator, anytime sine is 0, tan is actually going to be 0. So we know sine is 0 at 0 and also at pi and at 2 pi. So we know that this function will have at least those points on it. Now to graph this tan function, we can look at where it's going to be positive. We have a few points and we know it's going to go through the points and then get very close to the vertical asymptotes but never actually touch. But we also need to know where it's positive and negative. So from 0 to 2 pi, so I'll write 0, pi over 2, pi, and 3 pi over 2. This represents the unit circle, and again, all these functions come from the unit circle. So here we know that sine and cos are both going to be positive in the first quadrant, or from 0 to pi over 2. We can use it based on our CAST rule, like CAST. So cos, all, sine, and tangent. That's where each of these functions are going to be positive. Or we can just look at the horizontal and vertical components and seeing if they're horizontal or positive or negative based on the Cartesian grid here. So we have sine represents y, and it's positive in this quadrant. It's also positive in this quadrant. Cos represents x, so it's positive in quadrant 1, not in quadrant 2, not in quadrant 3, but also in quadrant 4. So that's why the C is there. So we know the tangent graph is going to pass through this point 0 here, or this point, and then it's going to get very close to but never touch this vertical asymptote. So that's one part of the tan graph. So next we have from pi over 2 to 3 pi over 2. So in this quadrant here, sine will be positive, but cos will be negative because we're going in the negative x direction this way. So that means that from pi over 2 to pi, it's going to be negative, because if tan is sine over x, sine is positive, but cos is negative. So that'll give us a negative value. So we know that this part, the tan graph will look something like that and go to pi there, because we know it has to pass through that point. Now from pi to 3 pi over 2, that's in quadrant 4. That's where tan is positive, and it's because we have a negative sign, because it's in the negative direction here in this quadrant, or the negative y direction, and it's also in the negative x direction. So these two negatives, a negative divided by a negative, it's going to make it a positive. It's going to kind of cancel out. So we know that this part of the function will be positive, going up like that. Finally, in quadrant 4, or from 3 pi over 2 to 2 pi, we know it's going to be negative because sine is negative because we're going in the negative y direction this way. So that means that sine is negative, but cos is positive, so tan will fully be negative because we have a negative sine and then divided by a positive cos. And we know it has to reach this 2 pi, and we know it gets close to this vertical asymptote, so it's going to look something like this. And that would be the tan graph. So cotangent is just the reciprocal of tangent. And if tangent's sine over x, that means cotangent is just going to be those flipped, so it's going to be cos over sine of x. So now the vertical asymptotes are going to appear wherever sine is 0. And we know sine is 0 at 0, pi, and 2 pi. So that's where we draw these blue lines which represent our vertical asymptotes. Next, we also know that wherever cos is 0, the cotangent function is going to be 0. So cos is 0 at pi over 2, so this point right here, and 3 pi over 2. So we know that the cotangent function has to go through that to evaluate this cos of 0. So the cotangent graph is very similar to the tangent graph. In this situation, now we've flipped the vertical asymptotes, we found out where the zeros are going to be, and now we just need to do exactly what we did before and figure out where this function will be positive and where it will be negative. So from 0 to pi over 2, that's the first quadrant right here. So again, all of the angles are positive in that quadrant because we're in a positive vertical direction and also a positive horizontal direction. So we know cotangent will also be positive. So that means if it gets very close to this asymptote, it's going to come down like this and then pass through this point. From pi over 2 to pi, it'll be negative because we're in this quadrant now, right? We've gone from 0 to pi over 2 to pi, then we'll go to 3 pi over 2, and then all the way to 2 pi, which is the same as 0. So we know it's going to be negative because from pi over 2 to pi, sine is positive, but cos is negative. So in this situation, we have cos being negative, and that will create the function to look something like this. Now we're going from pi to 3 pi over 2. Again, that's this quadrant here where tan is positive. And if tan is positive and cotangent is just the reciprocal of that, cotangent is also going to be positive. So it'll look something where it passes through this 3 pi over 2. And lastly, now we have the fourth quadrant from 3 pi over 2 to 2 pi. And cos is positive there, but sine is not. So the cotangent function will be negative, and it'll look something like this. So I hope this video is helpful. I was just trying to make a quick video to hopefully clear up some issues with the reciprocal trigonometric functions. I know they look kind of different, and if you're just getting started with trig, it's definitely pretty daunting to go from the trigonometric functions, which are already complicated, to the reciprocal functions. So hopefully this video helped. If you did enjoy this video, I'd really appreciate you liking this video and subscribing to the channel to see more videos just like this. I make a ton of content to help in math and physics, as well as improve the mindset and the learning skills of a student. If you have a specific topic you want me to cover, let me know in the comments down below. Thanks again, and I'll see you guys in the next video.